Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is decimal equivalent of a binary linked list. First of all, let us start by understanding the question. What does question say? Given a singly linked list of zeros and ones of length n. So we have a singly linked list which contains n elements and the elements are zeros or ones. That's why it is called a binary linked list. The task is to find the decimal equivalent of the binary number represented by the linked list. So that linked list contains the nodes which contains values ones and zeros. So if we put all of them together, it will represent a binary number. We want to tell the decimal equivalent of that binary number, where the significance of the bit decreases with increasing index. What does that mean? When you go in the right hand side in the linked list, the significance of the bit decreases. So the head node, the starting node, is the MSB, most significant bit, and as you go above, the value of the bit gets divided by 2. So if the current node has value 2 ki power I, the next one will have 2 ki power I minus 1 and so on. The last will be 2 ki power 0, all the LSB, least significant bit. The decimal value of an empty linked list is 0. So if the linked list is empty, you can return 0. Okay. Since the answer can be very large, output answer modulo 10 ki power 9 plus 7. For example, if you have a linked list this, so it is 0, 1, 1. What is the binary equivalent of 0, 1, 1? It is 3. So the output is 3. So this bit is 0 into 2 ki power 2. This will be 2 ki power 2. This will be 2 ki power 1. This will be 2 ki power 0. So 0 into 2 ki power 2 plus 1 into 2 ki power 1 plus 1 into 2 ki power 0. That will be 1 plus 2 plus 0. This will be 1 and this will be 2 and this will be 0. So the total is 3. If it is 4, 1, 1, 1, 0, and then if you write it in binary equivalent, then this is 2 ki power 0, 2 ki power 1, 2 ki power 2 and 2 ki power 3. So this is how much? 14. So the output is 14. Okay. You do not have to take input or print anything. Complete the function decimal value which takes a head node of the linked list as input parameter and returns decimal representation of it. The expected time complexity is big O of n and expected auxiliary space is constant, and the constraints are given here. So in order to solve this problem, first of all, let's understand the problem better with this example. So suppose you are given a singly linked list in which the values of the nodes are 1s and zeros. Okay. So now if you write the binary value found using these numbers, it is 10110. So now you need to tell the decimal equivalent of this number. Okay. And in the input, you will be given a head of the linked list. This is the head. Okay. So this will be the MSB. If you look here, this is the MSB. This is the LSB. So this will contribute 2 ki power 0. If it will contribute, this will have 2 ki power 1 value. This will be 2 ki power 2. This will be 2 ki power 3. And this will be 2 ki power 4. So this is how much? 2 ki power 1 plus 2 ki power 2. That is 2. This is how much? 2 ki power 4 plus 2 ki power 2 plus 2 ki power 1, which will be equal to 16 plus 4 plus 2, which will be equal to 22. So the output of the decimal equivalent of this linked list is how much? 22. So how will you solve this? First of all, you traverse the complete linked list and find the number of nodes. If the number of nodes is n, then the value of this bit is 2 ki power n minus 1, the next is 2 ki power n minus 2, the next is 2 ki power n minus 3, and so on. The last is 2 ki power 0. For example, when you traverse the linked list, here there are 5 nodes. Okay. So the value of this bit is 2 ki power 4, 2 ki power 3, 2 ki power 2, 2 ki power 1 and 2 ki power 0. So first of all, you calculate value of n and you will calculate how much each bit will contribute, how much maximum bit will contribute. Okay. So let's say this contributes 2 ki power 4. Now if this is 1, then you add 2 ki power 4. If this is 0, you do nothing. Then you, let's say this is your A value. This is 2 ki power 4. Now since this bit is 1, in your answer you add 2 ki power 4. Then this bit is, now you divide A by 2. So it becomes 2 ki power 3 for the next node. Now this is 0. So it will not contribute. So I will not do anything. Now again you divide it by 2. So it becomes 2 ki power 2. Now this bit is 1. So it will contribute to the answer. So you do 2 ki power 2. And again divide this by 2. So it remains 2. Now again this is 1. So you add 2 to the answer. And again go further and make 1. So this bit value is 1, but since it is 0, it will not contribute. So this will be how much? 16 plus 4 plus 2, which is nothing but 22. Okay. Now let's look at its actual implementation. So if we look at the actual implementation, so I have been given the head of the singly linked list. So first of all, I took a temporary node. I took a t, which is a pointer to a node type, and stored head in it. And I have taken variable I and n as 0. N will be the number of nodes in the linked list. Then I have taken one variable a. I have taken answer equals to 0 and mod equals to 10 ki power 9 plus 7. Now while t is not null, which was initially pointing to head null, I will say n plus plus and t equals to t dot next. So when I'll come out of the while loop, I will have the value of n, right? Now if n is 0, it means there are 0 nodes, simply return 0, right? And if not, see, this was how much? 2 ki power n minus 1, this was 2 ki power n minus 2, 2 ki power n minus 3, and so on. So first of all, I'll calculate 2 ki power n minus 1 and store it in a variable a, okay? So if you look here, what I have done is I have taken a equals to 1, and then for I equals to 1 to n minus 1, I have multiplied a with 2. So I have multiplied a with 2 n minus 1 times. So it will give me 2 ki power n minus 1. And every time I have taken the mod value. Now again, I took t equals to head and started traversing the linked list. If t data is true, it means if it is 1, it means in the binary representation it is 1, then this bit will contribute a to my answer. So answer equal to answer plus a modulo mod. Then I will move to the next node and I will divide a by 2. Because if for the current node the value of the bit is 2 ki power I, for the next node it will be 2 ki power I minus 1. So how do you divide? So whenever you are dealing with mod value and mod is prime, then what you can do is a divided by 2 is same as a multiplied by 2 ki power mod minus 2 ka mod ka whole mod. Okay. So basically instead of dividing by 2, you can multiply by 2 ki power mod minus 2. Okay. So that is what I have done here. I have multiplied with 2 mod minus 2 and mod. This is modular exponential function. It will give me the value of 2 ki power mod minus 2 modulo mod in log mod time. Okay, and then so a will basically get divided by 2. Other things done is just to satisfy the mod condition. So if I look here, this is the a, b and mod function. So it will return me a ki power b modulo mod. Now b is mod minus 2, so it will return me a ki power mod minus 2 modulo mod. So this is how much? Answer equals to 1 while b is greater than 0. If b mod 2 is 1, you can you multiply a with the answer, and at every step you do b by 2 and take a equals to a square. Okay, we are not going into the proof of this algorithm, but it will return you the value and then you return the answer. Now one thing what better you could have done is, see, every time this is no parameter is changing, 2 mod minus 2 and mod. So what better could have been done? I would have calculated this modular exponential of 2 mod minus 2 and mod in a variable, let's say p, only once, so that I do not have to call it every time. I can directly use it here, right? Because these parameters are not changing anyway. This doesn't take much time. So you divide a by 2, and every time whenever the bit value is 1, you add it to the answer. If the bit value is 0, you do nothing. Okay. What would be the time complexity? Here the time complexity would be big O of n, because you are using 2, 3 for loops. And what will be auxiliary space? It would be big O of 1, because you are using only a few variables. Now let's submit this code. Okay, so let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.